What is a continuum? Continuum. I am not going to teach English in this course, right? Continuum means something that never ends. It just goes in all directions forever, in space and in time. Things that Einstein liked, right? Things that are continuous and they never end, both in time and space. So if there's a continuum, we are part of a continuum. We are all part of a big continuum, time and space continuum. There is no distinction between space and time. We have learned. It's all part of the same thing. Energy, matter is the same thing, right? So you're just part of that. Everything is part of that. But if we break that down and out of that continuum, take out a solid, regular piece out of that continuum, physical, at one time, one instant of time, and then we say, okay, this is a solid that I'm going to deal with. This is a block of ice or block of something that you take out. I'm going to talk about this one. That block of wood or ice or concrete or whatever you take it, it's a solid taken out from a continuum at a particular time. And you say, okay, I'm going to have assigned 3 dimensions to that, z, x and y. Just doesn't matter, x, y and z, 3 dimensions to this one. And then if I say that all 3, x, y and z are nearly the same order, then I'm going to call it a solid. And the theories that govern solid are now different from other theories that we will talk about, right? So there's a whole field called solid mechanics that we don't teach in AIT anymore. I used to study, my professor was very, very tough at that time. I hardly passed that course. Very tough course, solid mechanics, because it dealt with continuums. Now we don't teach it because of the computers. We think that knowledge is not so essential anymore, right? So we don't teach that. Many universities don't teach that course anymore. So solid mechanics or solid, then if you go to this side and you say that one of the 3 dimensions is much smaller than the other 2 dimensions, we can call this as a surface type or 2D object. This is 3D because all 3 dimensions are important. Here it's called 2D because 2 dimensions are important. 3rd dimension is very small, so we can convert that into a property called thickness. And then whether that thickness is 1 centimeter or 5 centimeters, it doesn't matter, it is still surface. This computer is called Surface, you know. Microsoft came up with a very nice name for this one. I really like it. They call it Surface. So the thickness is something, so because its thickness is so small compared to the other dimensions, that they call it surface. And that's what we're saying. Surface type 2D object, right? When the thickness is much smaller than 2. How much smaller? We don't know. It's a big debate. What does it mean? Relative, but what does it mean? How much smaller? 5 times, 2 times, 3 times, 4 times? We can discuss a lot on this one. We will discuss this later. But let's assume that this is one type where thickness is much smaller than other type. So this is one surface type. On the other side, if we say that 2 of the dimensions are much smaller than 1 dimension, then we come to the bar type, line type. And this is what is our main topic for this course. Line type elements, in which 1 dimension is much longer than, can I borrow your phone and your pen? Yes, please. I will return, promise. This is category number 1, surface type. 2 dimensions are big, thickness is very small. This is category number line type because the cross section is much smaller than the length, right? So this is line type element, that is a surface type element. And if I can borrow this one, or I will not borrow, this is a cube or a block type element, which 3 dimensions are nearly similar. So you can see from here that the theories design is totally different for these types. We are going to start our study with this one. then we will go to that one, and then that one, in that order. Okay? Solid mechanics people start from here. In fact, they start from here, they go this one, and then they go this way. Now we will go the other way. Right? So let's talk about a bar type of element like the pen that I showed you, right? And if you take that and if you cut it across, you will see the circle or you will see the cross section of that item, right? So if I take a bar type, let's say the leg of this table, if I take this pipe and then I cut it, then I will see the cross section of that pipe. Or if it's straw that you have, if I cut it, I will see a circular hollow section there. So that is called the cross section. So the cross section will be exposed if I cut it at any location. So that is the, so if we take a plane and we cut a line element, we will expose the cross section. And so if I, this is the cross section of that line, so this is a general cross section, and that is our first topic, understanding the cross sections of the line type member, because everything comes from this onward. So we will understand the cross section. That's why this book is called cross section, structural cross sections, because it's so important to study this, because it will give us understanding of the members and go beyond that. Okay. So when we cut this one, so there's a center line and there's a length and there's a cross section, and then this is our first focus to understand cross section. This could be a beam, this could be a column, this could be a cable, this could be anything. This could even be a footing, it could be a truss member, it could be a steel, it could be concrete, aluminium, a sugar cane. Why not? Right? You cut a sugar cane, you see a cross section. When you cut a cross section, you expose the material, then you can see the material which is made from. For example, if I just show you this one, you're not sure what is it made from inside, but if I cut it, you can see the cross section. You can also see the material that is made from plastic, or maybe unlike a sugar cane, you see the outside, it is very solid and very strong. If you cut it, you will find that the solid thing is only very thin. Inside the pulp is very soft. So now we expose the material when we cut the cross section that we cannot see otherwise. So when we cut, we expose the cross section, and then we look at the material in the cross section. Now we have to understand the material, then we will understand the cross section, then we will understand the member, then we will understand the structure. So everything will start with material, then we go upward, understanding everything. So if we understand material, we will understand cross section. If we understand cross section, we will understand the member. If we understand member, we will go and understand the structure. So we can have the material inside: concrete, reinforced steel, pre-stressed steel, hot rolled sections, cold formed sections, aluminium and timber, and many other materials. So when you cut a cross section, structural cross section, you will find that it is made up of any of these materials or combination of materials. Or bamboo, why not? People use bamboo as a structural material a lot. So bamboo is just as good as concrete or steel. For us, it doesn't matter. We really don't care what material it is. We just want the material. Now let me go to completely on the other side of the problem. So that's one side. We're talking about one member. How does this member get its forces? What makes it act or react in a certain way? What are we interested in? Why do we need to study the material? Why? Nobody asked me, right? You should ask me, why? What's the problem here? So what's the problem here?
It needs to take some loads.
Correct. So it needs to resist something. It needs to carry some load. Because if I take your pen and can I borrow it? If I try to break it, then it is important to know what is it made of. If it is made from steel, I will not be able to break it. It is bad material. I will maybe break it quickly. If I take the straw, I can bend it. Another, I will not be able to bend it. So that means there is something in that cross section and material that is changing its ability to apply forces to it, right? So we want to understand that. Now, where is that coming from? On the other side. Let's take again a continuum, a structure which has no form. General structure could be a bottle, could be a table, could be my shoe, could be anything. Doesn't matter, right? Or even a cloud, as soft as a cloud. So, doesn't matter if anything here. And normally, every type of structure is subjected to excitations. Excitations means that it is always excited. It's always moving. It's always being disturbed. It's never at rest. The poor structures can never sleep. Why? Because always something is disturbing them. They are disturbed by themselves, called, no, self-hate is okay, but there's also another thing called